Good morning and welcome to this month's Southeast Climate webinar sponsored by NIDUS. I'm David Zierden. I'm Florida State climatologist here at Florida State University. Uh, so we'll go ahead and get started. I'm going to lead the climate discussion. And for this month, I'd like to really focus on the very strong El Nino that we've experienced this winter and some of the impacts, increased rainfall, storminess, cloudiness, other impacts. In my decades of living through and studying some of these El Nino events, this has been one of the most classically behaved and impactful events that I can remember since 1982-83, especially when we're talking about the Southeast region. So with that, we'll go ahead and get started. And here is just the Oceanic Nino Index from NOAA and also the Nino 3.4 Index from this past year. And we see that we entered El Nino conditions back in May of 2023, and it continued to gain strength through the end of the year in 2023. It looks like it's going to rank as the 5th strongest El Nino event on record since 1950. So that puts it in the very strong range. The Oceanic Nino Index, the past 3 months was at over 2.0 degrees Celsius. So it certainly qualifies on all levels as a very strong or historically strong event in the Pacific. But also, if you look at the graph on the bottom right, you'll see it is following the typical life cycle of an El Nino, where it tends to peak in the winter months, the Northern Hemisphere winter months, and they tend to quickly decay once we get into the spring and early summer. One other nugget is the 4 other very strong El Nino events were all followed by a transition back into the La Nina phase during the following summer. And currently there's a very strong forecast that we'll see that again this year, and I'll go into that a little later. So we'll go to the next slide, and this is just a review of kind of our conceptual model of how El Nino affects our weather and climate patterns in the winter months here in the southern United States and the northern Gulf Coast, the state of Florida. That region of excess heat and moisture from the Pacific Ocean tends to enhance the subtropical jet, and it brings a storm track that's further south and more energetic from California across the southern tier of the United States. Often these storms will re-energize, drawing on Gulf moisture and track along the northern Gulf across the state of Florida and up the East Coast. So that's kind of our conceptual model. We can expect more rainfall than normal, more frequent rainfall, maybe even cooler temperatures and increased cloudiness, and also severe weather. So we've seen all of that this year, which we'll go into. But I also want to highlight a real forecasting problem is, when does this El Nino pattern set in? It's usually late October to November, but it's a real forecasting problem for agriculture in this area, as October is typically the driest month of the year. They need dry weather to get into the field and harvest cotton and other row crops. But also, if the rains come too soon, it interferes with harvest. Too late, like I'll show you happened this year, it can also inhibit the harvest of peanuts, make them difficult to dig, and also the planting of cover crops and winter forage can be affected. So we'll go to the next slide and see what's been happening. Here's the temperature departure from normal for winter to date since December 1st. And we do see warmer than normal, which is right in line with recent decadal trends across Virginia and the northern portion of our region. But here along Alabama, Georgia, Mississippi, and the state of Florida, we were actually close to normal this winter so far, even a little below normal. So I think this is kind of the new reality. We can't expect colder than normal conditions from El Nino, but near normal is probably as cool as we're going to get. We also saw above normal temperatures across Puerto Rico and the Virgin Islands, running 1 to 2 degrees Fahrenheit above normal for the winter season. On the next slide, we'll look at precipitation, and this really shows the story. Excess precipitation above normal across nearly the entire region. We see a focus of 9 inches or more surplus since December 1st along parts of the Florida Panhandle, and also the Appalachians in interior South Carolina and North Carolina and Virginia. So there's a couple spots, the Baldwin County area of South Alabama, that's a little drier than normal, but in general, much above normal rainfall across the entire region. Puerto Rico and the Virgin Islands were more of a mixed bag, with some areas showing a surplus of nearly 4 inches since December 1st, others showing a deficit. So a lot of topographic effects on that island. So we'll go to the next slide. I was talking about this late start to El Nino, and over on the right, during October and into the early November, we had a streak of consecutive dry days, and I show that over on the right, 28, 30, even 32 days in a row without measurable precipitation during that time period. So it's very much a late start to the El Nino rains. Over on the left shows the US Drought Monitor from November 21st, where we had a quickly developing flash drought in the western Florida Panhandle, South Alabama, and even southwest Georgia. That went hand in hand with the longer term drought in the northern portions of Alabama and Georgia. So that's what we looked like back in November. But then fast forward, as we got into the latter half of November and December, the El Nino rainfall really kicked in. Over on the left are radar estimates over the past 90 days of rainfall departures from normal. And we see all from Texas along the northern Gulf Coast, the entire state of Florida, the Carolinas into Virginia, much above normal rainfall over the past 30 days. But it's not only the amounts of rainfall, it's the frequency. Over on the right is the number of days with measurable rainfall in the last 90 days. And again, in the Florida Panhandle, northern Gulf Coast, you see 28, 29, even some totals in the 30s in North Florida and into Virginia and North Carolina. So basically across most of the region, we've had rainfall every third day, which is really quite frequent. On the next slide, we'll talk about the increased cloudiness. And I got this image from Brian Bretschneider in Alaska, and he used the European reanalysis to look at cloudiness since the 1st of December. And you see the dark gray shading over most of the peninsula of Florida, where during this 80-year record, this has been the cloudiest winter to date, or December and January, in that 80-year record. So this just shows we also get increased cloudiness along with the increased rainfall from this typical El Nino pattern, and that extends up into Georgia, South Alabama, and the Carolinas. So the next slide, let's talk about a couple of these storms that are really energized by that strong subtropical jet and El Nino conditions. First, I'd like to look at the no-name storm of December 17th, a very potent low-pressure system formed in the northern Gulf. We had gale warnings from basically the coast of Louisiana around both sides of Florida and up into the Carolinas and the Cape Hatteras area. So a very broad and strong storm. The winds brought storm surge of 3 to 5 feet. Here I showed tide gauges from up and down the west coast of Florida, but also the east coast of Florida was also affected, as was the Carolinas, from just storm surge from the broad wind field of this low pressure. So the next slide, let's talk a little bit about El Nino and severe weather. And this is a lot of work that was done by the National Weather Service office in Melbourne, Florida. But with that more southerly storm track, as shown in the top graphic, that El Nino typically brings, and the upper level support from the strong subtropical jet, we see an increase of tornadoes and severe weather, especially across peninsular Florida, but in most of the southeast. And the bottom graph shows that during El Nino conditions, we typically see twice as many tornado reports than during neutral or La Nina. And also, if you look at the far right of the graph, the SE means strong El Nino, and that's where the majority of this signal comes from, is from these very strong El Nino events. And in fact, two of Florida's most deadly tornado outbreaks occurred during El Nino conditions in 1998, when there were 42 deaths. Also, February 2nd of 2007, 21 deaths and 76 injuries. And both of these events occurred in the overnight hours and really impacted mobile home parks and manufactured housing. And in fact, Chip Comrade with the Southeast Regional Climate Center did a study that showed, with the proliferation of mobile homes, manufactured housing, and an aging population, Florida is the most vulnerable state in the world to these kind of tornado deaths. So we'll go to the next slide. This year's been no exception. These are the severe weather reports since just since January 1st. And we see a cluster of tornado reports along the Florida Panhandle up into Southeast Alabama, Southwest Georgia, also in South Carolina. Even last week, we had several reports of tornadoes in Southeast Florida, the Miami-Dade and Broward County areas. So all very consistent with this southerly storm track and increase in severe weather. So with the next slide, we'll take one more snapshot of another one of these storms that, or low pressure systems, very energetic, that formed in the Gulf of Mexico. Over on the left is the radar loop, as in the heart of the convection from this low pressure system, a meso-low formed and came ashore at Apalachicola and impacted the Florida Panhandle. And over on the right, I just have the different meteorological variables as the center of this meso-low came ashore. We see a spike in water levels or tide levels of about 2 feet, a sudden drop in temperature of about 6 degrees Fahrenheit, a sudden shift in the winds from 30 knots from the southeast to winds out of the northwest. And you also see the barometric pressure just bottom out at 992 millibars as the center of this meso-low came ashore. On the next slide, this meso-low and the dynamics of how it all evolved actually brought some severe weather to the region. Tornado reports in Madison, Florida, in Duval County, and also in Valdosta, Georgia. And this was on a day where the convective outlet really didn't have us in much of a risk, but just from the dynamics of how this low pressure evolved, we did get some tornado spin-ups. Bottom right shows some damage in Valdosta. Again, a mobile home that was destroyed there. So this kind of a little off subject, but it is very pertinent. Also in the background is the warming North Atlantic Ocean. Over on the left, we saw it, the temperatures of the North Atlantic from 0 to 60 degrees north began running at record levels almost a year ago in March of last year. And that continued through the summer and the hurricane season. And it continues today. Over on the far left of the graph, you see 2024, where we're now even eclipsing last year's record warm North Atlantic temperatures. And over on the right is just shows the sea surface temperature anomalies, very strong warming over in the Eastern Atlantic in the Cape Verde area. So this really spells bad news for the upcoming hurricane season. So next slide, we'll take a look at the current drought situation. Over on the left is the drought monitor from our last webinar, where portions of Northwest Alabama, Northern Georgia, and especially Tennessee were still being affected. But with the plentiful rainfall, most of that drought has been eliminated. We see pockets of D0 or abnormally dry in coastal North Carolina and northern Alabama, but no real areas of drought anymore with this plentiful rainfall we've seen. So next slide, we'll look at Puerto Rico and the Virgin Islands. They still are under moderate drought to abnormally dry conditions and have not changed much in the recent month. So we'll start looking ahead now. This is the quantitative precipitation forecast for the next 7 days. We see another potent winter storm is going to be affecting the West Coast and California Very high precipitation amounts forecast there. Some precipitation in the northern Gulf Coast, Louisiana and Mississippi coast, but for other parts of the Southeast, Florida and the Carolinas, not as wet in just the next 7 days. However, looking further out, which I don't have graphics for, the week 2 period shows a continuation of this active pattern. So we can probably look for more storminess and more rainfall in the 7 to 14 day time frame. We'll go to the next slide. This is kind of hot off the presses. This is the latest forecast for the El Niño La Niña cycle. Some highlights: it shows 100% chance of continued El Niño conditions through February, March, and April. But then it indicates a fairly rapid decline in El Niño, and then the transition to La Niña conditions becomes more and more likely as we get into the summer months, June, July, August, especially as we get into the heart of the hurricane season, August, September, and October. And what's curious is we are currently, according to NOAA, under an El Niño advisory, which means we are in El Niño conditions, but at the same time, we're in a La Niña watch, meaning that La Niña conditions are increasingly likely in the coming months. And I'm not sure I've ever seen both of those issued at the same time. So with the next slide, with that in mind, we'll look at the 3-month temperature and precipitation outlook from NOAA's Climate Prediction Center. Really no strong forecast for temperature, showing just equal chances of above or below normal across most of the Southeast. However, the 3-month forecast is hanging on to this idea of El Niño and an increased chance of above normal rainfall for all of the region. And on the next slide, we'll look at the drought outlook. Since drought has mostly been eliminated from this region, it really doesn't have a lot of information. It doesn't indicate that drought should develop anytime soon, which is, again, is consistent with that 3-month outlook. And with that, I think these are my closing kind of summary points, which I'll let you read on your own. And I'll pass it over to Todd Hamill with the Southeast River Forecast Center for our hydrologic discussion.
Thank you, David. All right, so we'll go ahead and continue on into the outlook. And the next slide, you'll see this is Todd from the Southeast River Forecast Center, as most of you know. And so here's the 28-day stream flow average across the Southeast. And a couple of things I want to point out. This is an overall look at the whole Southeast. And so this is, like I said, a 28-day average. And if you look on the left-hand side, you can see stream flow averages and a couple of areas to point out for the less rainfall. And one of them is down in that Mobile area where we've had below normal rainfall in that area, and stream flows are following along with that. And the other area of interest is up in the Eastern Carolinas, where we're seeing stream flows, especially ones that originate in the Piedmont and the coastal areas of North Carolina, where they're below normal this time of year. But as you look at the right-hand side and just generally over the whole Southeast, you can see we've gone from what we were in November, as David mentioned, with the drought monitor and how dry we were at that time, and how we are very wet right now. We did expect this. We were looking for this. And so, obviously this is not unexpected. We stay wet in general for the whole Southeast. But I'll show a graphic later that talks a little bit about that. We still have some dryness in the area, and that's not unusual. So let's go ahead and go to the next slide and look specifically at some of the states, and you'll see very similar patterns in each one of these. Our duration hydrographs, these are again 28-day averages. And on the first one on the left-hand side is Alabama, and it showed dryness for a longer period of time as it was more slow to come out of drought. And our events in Alabama and Mississippi came a little bit later. And so it ended up, but it has come out of drought for the most part, and we're in good shape there. If you look at Georgia, we've had some pretty good flooding in Georgia over the last couple of weeks with our most recent rainfall event, our big rainfall event. And then Florida. Now, Florida is still very interesting. This is supposed to be their dry part of the year. And I hadn't seen David's graphic about how cloudy it's been there. But in addition, so they've been cloudy. They continue to see rainfall, and this has kept them wet during their dry time of year. So it'll be interesting as we move through the spring and into the summer and their wet season to how it will impact their rivers as we go into the summer. They'll be in probably pretty wet as we get into the summer, so that could be potential for some flooding as we head into the summer months. So let's move, let's go to the next slide and move a little bit further north and South Carolina. And you can see South Carolina, North Carolina, very much similar patterns where we went from very dry to pretty wet, almost in the 95th percentile, the highest percentile as we move through the January and early February timeframe. One of the things you'll notice as we get into North Carolina is I think some of the dryness in the eastern half of the state is impacting those stream flows, and so we're still in the normal range, but we're starting to creep down close into the below normal, just because part of it is an above normal, part of it's below normal. So so we may exit the winter possibly if we don't start to see rainfall going down during this time, and that's not a good sign as we start to talk about drought. We'll have to watch that closely as we move through the rest of the winter and into spring, and see how that impacts it. Virginia is in much better shape also. They were very dry as we started the winter, but are in good shape now. So let's go ahead and go to the next slide. And this is just a couple of slides showing where we were on February 15th, just a couple weeks ago, where we had some pretty significant flooding across the southeast. This is typically what we expect during an El Nino year, and that has happened. We didn't get a lot of the rain stayed on our southern tier states in Mississippi, Alabama, and Georgia, and just a little bit of northern Florida. We didn't get as much in the Carolinas, at least in North Carolina and Virginia. And so it has taken a little bit of time. We still have the lower part of our rivers that are seeing some flooding from that particular event. So we'll watch over the next couple of weeks to see if we're going to get that rainfall that we would expect during this time of year. So let's go to our climatology, which is in our next. And so we're in week 9 during our year. And really, this is our flood recharge year. Now, this particular graphic has nothing to do with the El Nino and La Niña. It does include all of those years. This is our climatology for the year, and you can see that this is when we typically peak in this kind of end of February through part of March, and see our highest stream flows in the southeast. And this is a benefit for the southeast in recharging reservoirs, recharging soils, but it also can be potentially flooding. And these are describing the floods in the southeast. We've been fortunate over the last couple of weeks after our last rainfall event to have a little bit of dryness as we approach March and the peak of that season. So I think we're at least in decent shape. If we start to see some rainfall, again, it's something we're going to have to watch very closely because it is our most active time of year. We are still in an El Nino winter into spring, and so the potential is still there for flooding. So let's go ahead and go to the next slide, and this talks a little bit about Florida very specifically. And almost nearly all of these floods that you see in the winter in Florida are from El Nino years. And so this is the time when we expect flooding in those areas. We've been fortunate that we've seen a little bit of flooding, but we still haven't seen really extensive flooding. We've been wet. So again, we'll watch that through this time and see if we continue to stay wet at least, because as you see, as we approach the summertime, that's when we expect most of the flooding in Florida. So let's go ahead and go to the next slide. So I show this, we've been showing this through the whole El Nino year, to talk about stream flow anomalies during an El Nino. And this is the last time I'll show it because we'll be heading out of an El Nino. But one of the things I wanted to show is that even though we expected us to have some flooding during this time, during El Nino years, we have had times when we have been below normal in stream flows. And if you look on the very right side, you see there's green, which shows above normal stream flow. The yellow shows the near normal, and the red shows below. And in that Eastern Carolinas, we still just have had years where we have been below normal during that time. And so that is not, while it's not normal to see the below normal stream flows, or it's not during an El Nino year, we usually expect to see flooding and higher than normal. There have been years when we've seen below normal. And so seeing that a little bit sparsed across the Southeast is not an unusual thing. And that's just kind of what I wanted to highlight. But overall, we've seen above normal stream flows. So these forecasts and how we'll add to these analogs as we add this new year will help inform this graphic when we get our next El Nino. So let's go ahead and go to the next. And so again, we continue to have above normal risk for river flooding across the Southeast. There's still a concern for flooding as we're still pretty wet, and our temperatures have been pretty normal across the Southeast. So the potential for flooding is still there. The only place that maybe is a little bit less is maybe in that coastal region of North Carolina. I include it anyway because it still won't take a whole lot to start to see flooding if we start to see rainfall move into those areas. And so with that, this is just my summary slide, and you can read this at your leisure. And if you have any questions, we'll be answering those in just a little while. And with that, I will pass it off to Pam for our for agricultural stuff.
All right. Well, thank you, Todd, and good morning, everybody. I will apologize in advance if I start sneezing because the pollen is rising, and I can tell. So let's jump right in. Here's some of the summaries of recent conditions. Of course, a lot of agriculture is still in the preparation stage because we're not out of the frost season yet, but farmers are really anxious to get out there. The rainfall has helped most crops, but there are some wet soils in some places, especially the areas that are more clay soil instead of sandy. And so they've been having some trouble getting into the fields for those particular locations. Water tables have been replenished in a lot of cases. That'll help later this summer if irrigation is needed, which it very well may be as we go into neutral conditions and then into La Nina. Some of the crops like onions are doing very well. Have been some early reports of some of the earliest blooming varieties of peaches are starting to blossom. I've also seen some reports of some blueberries starting to bud and bloom farther to the south. Here we're talking mostly about Florida and southeast Georgia and coastal South Carolina. The cooler weather and excessive rain that we had in early February made it hard for cattle producers to provide enough forage. Things just were not growing, and they've been feeding hay, but hay supplies are running short in some places. So the later half of the month where we had warmer temperature and a little bit more moderate rain has really been good for pasture and forage, and also for small grains. So that's been good. If you look forward in time, people are asking me now, have we seen the last frost? Well, if you look at the long-range models, and you have to take those with a big grain of salt, we don't see a lot of frost in a lot of the region except for higher elevations in the southern Appalachians. But, we're a long ways from frost, and I have a slide about this in just a minute. So I think at this point, most people should probably not be planting yet because the potential for getting colder weather or late frost is still there, even though it's been warm lately. So let's go on. The soil temperature and moisture, these are both relatively shallow layers. You can see that Alabama is relatively cold in temperature. That's probably in part because it's been pretty wet there as well. Whereas Virginia and North Carolina have been warmer, and they've been drier as well. So that probably makes a difference. If you have really wet soils, it's hard to raise the temperature of those. Soil moisture is quite dry. This is just the top layer of Alabama and Georgia. It's drizzling here in Athens today. I don't think we're going to get a whole lot of water content out of that, but we will probably see more later tomorrow as the front comes through. If we go to the next slide, there we go. The green wave, which I like to call the advent of spring coming into the region from the south. And the left-hand map shows the first leaf index for spring. You can see it's covering most of the southeast now, except the higher elevations. I noticed it a couple weeks ago with the honeysuckle in my yard. It's about 2 weeks early in most places. The first bloom always lags that for a while, but you can see it's crept up already into a lot of southeastern Georgia and southern Alabama and coastal Carolinas, and those are for honeysuckle specifically, I think. So there's other species will bloom earlier or later, but we're definitely going into that time of year, and so that is something that we'll have to watch. You can see that colder temperatures earlier in the season caused a delay in the first leaf out in northern Florida. But we have caught up with that and far exceeded it as we've gone through this fairly warm period. So if we go on to the next slide, this shows the daily temperature normals and the actual values for Augusta. Just sort of picked a spot between Georgia and South Carolina in the Peach Belt. And you can see, I mean, for a lot of the winter, the gray bars that indicate the actual temperatures were below the green bars, which is the normals. But since about late January and then early in February and then lately, those temperatures have become much more moderate, and some days have definitely been well above normal. But that warming has been enough to really start to wake up some of the plants, and so that has contributed to the low chill varieties of peaches that have started to bloom, although it's certainly not widespread bloom at this point. If we go on, we think a little bit more about frost. The average date of last freeze is on the left-hand map there. This is from agroclimate.org. And you can see that for the center part of Georgia, stretching into the southern part of South Carolina and Alabama, the light green there is the first week of March. So we're not even there yet. And so that shows that we're not even to the average frost date for a lot of the northern part of the southeast. So the likelihood of frost is still fairly high. And if you look at the 1 in 10 chance, which is the right map there, you can see that in central Georgia, where we have a lot of the commercial peaches, the 1 in 10 frost date is the end of March. And so we still have a long way to go before we're out of frost. And of course, Florida is a little bit earlier than that, so they're busy planting right now, and there's also some peaches and blueberries that are starting to bloom there. So if we go on, the chill hours this year have been better than last year. This is for Peach County, Georgia, which is just south of Macon, and you can see we've already had more chill hours this year, 877, than we did last year, and we'll probably gain a few more, but I think it's going to be fairly warm, so we'll probably follow the bottom edge of that red envelope there. It's been better than last year, but it's going to slow down a bit. I think the peaches are pretty much just waiting for another spell of warm weather before they're going to start blooming. And of course, since we're not out of the frost season yet, that is definitely a concern for us in the southeast this year. There's not much we can do about it at this point, but just really watch and wait. Peach growers do have some methods for trying to delay the bud, and I'm sure they're looking at those. So if we go on, here's my summary, and so I'll let you read that at your leisure. And now it's my great pleasure to introduce Jeremy Hoffman, who I've been working with for the last couple of years on the Southeast chapter of the 5th National Climate Assessment, and Jeremy is going to give a summary of what we learned in that. So take it away, Jeremy, and I'm really excited to hear what you have to say.
Well, thank you so much, Pam, and the other panelists so far. It's an honor to be here this morning to share with you a little bit about the Southeast chapter of the 5th National Climate Assessment. I encourage you, if you haven't yet had the opportunity to explore the report, it is the website is extremely accessible. There were several art-related projects associated with this year's late last year's release. and an interactive atlas. And so this year, NCA 5 contains a variety of different chapters covering both physical science and topic chapters, things like, economics, which is a new chapter this year, social systems and justice, which is a new chapter, things like land cover and land use. Those are these kind of topical chapters which explore nationwide patterns in these underlying particular sectors. And then we have regional chapters that focus on a particular geography within the United States, in which includes the Southeast, which is the chapter that I was the lead author on, and helped by Pam Knox, among many others, maybe some of whom are on the call as well. I wanted to provide a little bit of background on how we went about doing the Southeast chapter and some major timeline pieces. Most important aspects, I think, of our process are highlighted here in the yellow. We held 6 different public and stakeholder meetings around the early development of our chapter. So we kicked off with an author team meeting where I asked my authors to individually, explore what would be the kinds of topics that you would want to write about. If you were the only person writing this chapter, what would you want to write about? And then I asked, and we asked our participants, which included youth audience as well. We had them explore that same question. If you were going to write the 5th National Climate Assessment chapter on the Southeast, what would you focus on? And we're really, really happy that much of what we explored as an author team early on and what we heard back from those 6 independent audiences over the course of early 2021 and even into 2022 aligned very closely. And I'm sure that comes through. If you haven't had the chance to read the chapter yet, I think it's fairly obvious what were the major topics that not only had been covered recently in the literature, but were really, really relevant to the audiences across the Southeast that might access the 5th National Climate Assessment. We also later on, just before the end of 2022, we had our National Academies peer review and public review. We had close to 75 comments and 3 whole pages of National Academies review. It was extremely thorough, and we were very, very thankful for the individuals that provided some feedback on our drafts. And the publication of the 5th National Climate Assessment was in late November, or in early November 2023, so it's still relatively new and hot off the press in some ways. I would encourage you to go explore. If you're a data person, the National Climate Assessment has an interactive atlas, yet another online tool that we can use to access the data that could help inform decision making across our region and writ large across a variety of different sectors. Atlas.globalchange.gov to explore that. I wanted to make sure that that was highlighted. Now, the Southeast chapter in particular, I think, does an excellent job in exploring the historical and kind of decision-making processes that lead to present and future risks relevant to climate change impacts in the Southeast. So this is, I think, the figure from the first chapter, Climate Trends, looking at all of these different kinds of, or the overview chapter, looking at just writ large, what are some of the large scale patterns that we see and in the present, and then depending on decision making around carbon emissions trajectories, what could global change in the country look like here? And so what the biggest piece of what we've tried to talk about in the Southeast is how these global changes relate to local risks in our region, and how the urban planning and other forms of decision making that have happened in the history of the Southeast shape the exposure and vulnerability to risks. So throughout the chapter, I think you can see that we've made an effort to relate kind of history to present, and how the present then informs all else being equal, what the burden of the future might look like. So many times we've juxtaposed some sort of socioeconomic data to present day climate exposures or future exposure given a certain global warming scenario. And most of the time, we've actually focused our projections, our conversations around projections on the intermediate scenario, so SSP 2 to 4.5, mostly because that's the most close to our carbon emissions trajectory in the present. And we've very much, thankfully, gotten off of what would have been called RCP 8.5. So some of our chapters across the NCA are summarized into key messages, and we have 4 key messages. The first one being that our remarkable amount of growth has actually increased the amount of climate risk that we experience in the region. This is probably the most explored through patterns of population change. And so on the left here, a map of the Southeast. Again, our region is comprised from Louisiana up to Virginia, down to Florida, and then back up to Kentucky. 11 states comprise the Southeast region in the NCA. And so the blue areas are places where we saw population growth since 2010. And then on the right, that's a map of where under a kind of moderate scale population change or economic future projection, in the future SSP2, we have further, those blue colors are again associated with growth in population. So we know and see that many of the largest growing metropolitan areas are in the Southeast, and we've seen a lot of growth along our coastlines. And so this moving people into places like urban centers that continually sprawl outward, and coastal areas, which are in the Southeast, exposed to threats that are exacerbating or being exacerbated by climate change, including sea level rise and hurricanes, that this is a challenge in that we are putting more people and things into harm's way while losing the capacity and population in rural areas to deal with their own and similar kinds of threats from a changing climate. So we have a very unique kind of reorganization of where climate threats are focused and where the people and things that we care about are in relation to those threats. Now, we also see that much of this growth in population actually isn't in the downtown urban cores or the land use change associated with this growth is not in urban cores. It's actually on the periphery. It's on the ex-urban periphery. So we've been looking at this kind of land use change. The Southeast has the largest amount of land that transferred from a forest to developed land cover than any other region in the entire country. We've lost about 2 million football fields worth of forested land to developed land cover over since 1985. This, of course, is the quintessential expression of the expanding bullseye, kind of that work of as you spread people and things over a larger area, the same kind of threat like a tornado or wildfire or so on has a larger and more significant impact. And so this, we talk about this as a growing threat related to land use change in relation to growing climate threats, as well as securing the kinds of areas of biodiversity importance that make up the very unique Southeast region, which is the most biodiverse region of the continental US. This is juxtaposed also in the chapter by explorations of things like billion-dollar disasters, as well as specifically hurricane landfalls. Very great work from Kim Wood, who's now at the University of Arizona, on that plot on the right. Now, with these kinds of flood and storm and extreme weather-related threats, of course, disproportionately affect disproportionately exposed communities and historically marginalized communities. On the left, we see rental housing units at risk or at even moderate risk in the FEMA risk index, and then on the right, you can see projected changes in flood-related annual losses concentrated along the coast in particular areas within the Southeast. Some of those places have currently high related risk, and in the future that continues to be exacerbated. Some of these particular counties are the exact same ones that pop up in both data sets. Now, we also provide in this part of the chapter an updated estimate of sea level change and associated high tide flooding risk. This uses, of course, the NOAA sea level rise projections from Sweet et al. We share this about Jacksonville, Florida, where major flood events like those experienced during really only hurricane conditions, Hurricane Irma in 2017 being the latest and most significant major flooding event. These major flood events become about 5 times more likely under 2050, even under that intermediate high sea level rise scenario, which tends to be matching the trajectory of observations. So these are very large changes also to minor and moderate scale high tide flooding. So there's some real serious conversations around infrastructure in coastal communities that is juxtaposed particularly among that growing population. How do we keep people out of harm's way and continue to grow in the Southeast, secure the vitality of our communities, even among these sorts of climate changes and climate threats? We share some really exciting examples of how that's being done in the Southeast, as well as some design, the urban design things that have been coming up more and more through the region over the last couple of decades. Now, our second key message is focused entirely on climate change and health. We talk about present day health inequities in the Southeast. We have some of the lowest life expectancies in the country and some of the highest levels of social vulnerability, and many times these two things overlap. This is, of course, kind of provides that social determinants of health, and then how climate change threats like extreme heat or extreme precipitation or wildfire or drought can then further exacerbate those present day health inequalities. We talk about this in relation to extreme heat. On the right, we have the change in the number of days at or above 95 degrees. And on the left, we have a map that has dark blue areas where there's high people of color percentages in the population and high amounts of energy burden. So taking these three things together, these are places where people are already experiencing a high level of their income being spent on their energy bills. These folks then are also more likely to be renters, more likely to have chronic illnesses, and these same places will see some of the most significant increases in the number of days at or above 95, showing that kind of juxtaposing the present day and the future and disproportionate exposure. We also explore interesting new data sets such as warm season blackouts. We show that many of the blackouts affecting more than 1,000 people for more than an hour occur in the warm season. This, of course, is not ideal for a region that relies primarily on indoor cooling to keep people safe. We also explore things related to the kind of what's known as the climate penalty for air quality in the future. The Southeast, because of high amounts of vegetation and otherwise, actually still sees changes to our air quality that disproportionately affect people that are 65 and older. And we see some places in the country or in our region that actually see an increase in the number of premature deaths for those vulnerable populations in the future, kind of just due to this climate penalty. So the more that we allow global warming to continue, the more that this climate penalty worsens our air quality into the future with no change to the emissions of those same precursors. We also explore, of course, in our key message 3, we want to talk about jobs and the economic security of our region. This map is interesting in that it shows places where the color is the lightest gray is really the places that are the most significantly potentially under underprepared for rural climate risk challenges. So light gray indicates places that have very low rural capacity indices, which is like the engagement with local elections, having city staff for particular amounts of, or a particular amount of city staff in a city governance, as well as areas that have very low household incomes generationally. So these are places that basically poor children born to poor parents are still poor when they reach age 35, is what these data relate to. So the lightest color areas experience both really low rural capacity index values and low generational upward mobility. So we can see some of the kind of geographic highlights of other maps in this same chapter tend to come up. You know, this kind of the black belt in many ways shows up in a variety of these different indicators of you know, community and socioeconomic health. And we also talk about how investing today offsets future damages. This is one of those where we have, you know, GDP under RCP 8.5, which is not the projection that we tend to use. But we also talk about, you know, the kind of regional impacts of extreme weather events and how these are related in some ways to exacerbations from climate change, like flooding, droughts, extreme floods, and then low flow events on the Mississippi River, which we tie to the Calcasieu Lock and Dam and its county-wide impacts outside of the Southeast region. So we have a really interconnected dependence of our economic systems. We also talk about how investing today offsets costs in the future. So proactive adaptation to things like our transportation networks, both road and rail, offset billions of dollars in the future, as much as half, if we take proactive adaptation to secure those, as well as not only our transportation networks, but we talk about energy grid resilience. So on the left is the cost associated with proactive adaptation in 2030. Match that to the map on the right where we have no adaptation, tends to be about half again. So the more we spend in the present on strengthening our electrical and transportation infrastructure, offsets significant future costs that most of the time are passed on to residents and consumers. And so we also spend one critical thread throughout the chapter, which I hope you will notice in your read through of it, is that we continually weave in and out stories of the indigenous peoples of the Southeast region. And one of those is a highlight box focused entirely on the Gullah Geechee Cultural Heritage Corridor. They worked with FEMA to rewrite some policies relevant to heirs property, which is actual ownership of property, but with very little legal documentation. So that made it very hard to funnel FEMA money into these folks' hands in advance of climate threats like hurricane season. So we highlight, and they wrote their highlight about the Gullah Geechee experience, kind of reshaping some of that FEMA policy. We also focus on native bamboo river cane and how that's culturally a really culturally important native bamboo to many tribes in the Southeast, and how it has a historical range that is significantly, hugely larger than the present day range. And we kind of highlight a little bit about that story as well. You'll see it in other ways kind of pop up across the chapter as well, but I wanted to highlight those two in particular. Then last but certainly not least, as you heard from Pam, agriculture you know, faces these continually growing threats from things like earlier you know, bud and bloom in relation to freeze events and so on. And the more innovation we can provide in the present might secure that vitality into the future. We talk also about how even within the agricultural world, there tends to be disproportionate exposures and outcomes for marginalized communities. The Southeast has the highest proportion of Black farmers, and they tend to have experienced some of the highest count of drought events. Now, that doesn't mean that drought is intentionally happening in these places on purpose. It's just that where these places are located in relation to the last 20 or so years of drought events tends to be disproportionately high. So we talk about the kinds of and you can see here also that kind of quintessential black belt geography for the Southeast is even retained in something like the drought counts and the climate risks associated with farming. We also talk about the RCP 8.5 specific impacts on agricultural yields and reflect on the fact that there's loss in some places, lower agricultural yield projected by this, as well as some places that might actually see a climate benefit from in yields, particularly under very high warming, which is no longer necessarily the most likely scenario in any case. But please, I encourage you to go and dig into the text. We had a huge team representing, federal, state, local, nonprofit, all sorts of different folks contributed to this. I want to give a special shout out to Stephen McNulty, who was our federal coordinating lead author, and Eliza and Joshua at USGCRP that helped coordinate the whole thing. And Tisha Holmes from Florida State was our review editor. Just an absolutely wonderful experience working with Tisha on making sure that we were documenting all of our review changes. So please do take a look. Go see it at nca2023.globalchange.gov. We're chapter 22. And thank you for your attention this morning. Happy to have a little bit of time to talk through maybe one question at the end here. Thank you very much.
All right, my name is Eleanor Hassenbeck. I'm a communication specialist here at NIDIS, and I'm gonna lead the Q&A and wrap things up in just a moment. And I'm sorry, I'm just having just a little bit of difficulty with my slides, so you're gonna have to, you're just gonna have to hear my voice. We're gonna send out our summary and a recording of the webinar to folks who are subscribed to NIDIS emails on Constant Contact. Otherwise, you can view that recording at drought.gov/webinars. We have 2 webinars coming up on March 26th. Will be the it'll feature the US Phenology Network and the 2024 pollen season. So if you are really excited by the graphics Pam showed about the leaf index and the first bloom index, it's gonna be all about that. So join us then. And April 23rd, the special presentation will focus on tornado vulnerability in the Southeast. There will be a survey after this webinar to let us know how we did and what you'd like to see in future webinars, and you can always contact us. Meredith Muth is the drought early warning coordinator for the Southeast region, and her email is meredithfmuth@noaa.gov, and I will put that in the chat in a moment. But just to get to questions, we have a couple for Jeremy and one that maybe Todd and Jeremy might be able to answer together. But first, Jeremy, are these maps available for other regions of the US?
Somewhat, it all depends on whether that same data set was used by that particular chapter. So in some cases, there are in the Atlas, I think they've provided some of the social vulnerability index data, for example, but yeah, I think we're among the only regions that really kind of juxtapose that social and socioeconomic data in relation to the climate data. So you'll have to go to the report to find out.
Alrighty, and that link is in the chat as well. And then we can try really quickly to answer one more. And this one, maybe Todd, maybe Jeremy can answer. In areas such as Jacksonville, how much of the flooding is caused by surface water runoff and how much by ocean surge? Does anybody want to take a crack?
Well, certainly, I think that there's clearly in the event of things like hurricanes, onshore storm surge is a huge exacerbator to those sorts of flooding conditions. But many times, like especially with a hurricane, you can have kind of compound flooding. So you have both runoff related as well as storm surge related flooding at the same time concurrently, and those are really significant. But we also know that there's, the advent of, especially if it's a rainfall event coming from the west, that can drive, runoff related. So it's really dependent on the particular event that you're talking about. But in this case, in the future, much of that is dominated by this increase to baseline sea level brought on by that like chronic high tide flooding.
Alrighty, and I do think we're out of time for the additional questions, but we have your emails and we can try to connect you to the presenters to get those answered via email. So look out for that if you have a question that we haven't gotten to. Otherwise, thank you all so much for tuning in. Thank you so much to our presenters for giving us all this excellent information, and we hope to see you next month. Thanks so much, all.